So there are four main inputs to the MRP system. The first one is MPS or Master Production Schedule. Second is Bill of Material. The third is Inventory Data. And the fourth is Planning Factors. We have already discussed MPS or Master Production Schedule. It gives information about the quantity of end items required and the time when they are required. And once we know the requirement of the end items, we can calculate the requirements for the components and raw materials. So MPS along with bill of material helps in determining the quantity of the raw material and the components and when they will be required. And for that, we need information on the lead time as well as the lot size policy. So such information is contained in a separate file or in the same file that has inventory data. So these are called the planning factors. And inventory file or inventory data file contains the latest information about the status of the inventory of a certain item. So what is the quantity that is available? What is the quantity that is on order? What is the quantity that has been allocated and so on? So we will go through these inputs except MPS because we have already discussed it in detail. In fact, we have already discussed bill of material as well. But we will just touch upon bill of material and see how it helps us in what we call exploding the requirements. And we will see the example of an inventory record and some examples of planning factors. So this is the summary about these four inputs. So first MPS. It gives us the information about end item quantities and end item due dates. Then the product structure that contains the bill of material that gives information about the components required and quantity of each component per parent. And there are some optional factors that could be there in the product structure file like yield and scrap factor. The inventory record file gives us information about inventory balance status. So what is the inventory of that component on hand? What is the quantity that is allocated and what is the quantity that is on order and some other information as well. Then item planning file might be a separate file or these two might be the same file. So that contains information about planning factors. So what is the lot size in what quantity do we purchase the item or make the item? What is the lead time in case of purchasing? What is the purchasing lead time? And in the case of in-house manufacturing, what is the manufacturing lead time? And it may also contain the yield or scrap factor. And an important element in the planning file is the safety stock. And it could contain order policies as well. So again, MPS drives the MRP system by providing the end item due dates and quantities. Bill of material provides list of components as well as quantity of each component per parent. Inventory record file to find out how many are needed, the quantities available must be considered. The MRP system needs to know how much is available, how much is allocated, and how much is on order. So this file is a dynamic file and changes with every transaction that takes place. So conceptually, we have a separate inventory file in the ERP system for every component. So these data are maintained in a file that is sometimes called inventory record file or also called item master file. Each item has a record and all records together form the file. And the fourth input to the MRP are the planning factors. So we have already seen what is a bill of material, what are its different formats. So it is an example of indented bill of material. So the indents are showing the level of the component or the sub-assembly. And we also know the quantity of each component required for each of its upper level components, that is called the parent. So this bill of material, as I mentioned, has different formats. This is indented bill of material. Here is an example of multi-level product structure. So this is the end item, final product. It comprises two components, in fact, one component A and other assembly B. So assembly B also has two components, C and D. And the quantity of each required to make one upper level component or assembly is given. For example, in order to make one parent item, we need one component A and two assemblies B. And in order to make one assembly B, we need three components C and four components D. So in this case, how many component Ds will be required to build 20 units of the parent item? So we need 20 parent items. So in order to make one parent, we need two Bs. So in order to make 20 parents, we need 20 into 2, that is 40 Bs. So in order to make one B, we require 4 Ds. So for 4 Bs, we require 40. For 40 Bs, we require 40 into 4. So that is 160 Ds. So we need 160 Ds to make 20 parent items. So this process is called exploding the bill of material. So we are multiplying, starting with 20, then 40, then 160. So this is called exploding the bill of material. So this is the process of determining the component quantities per assembly. We need 20 assemblies, so we need 160 components D and 40 assemblies B. So this was a simplified example to give you an idea how bill of material actually helps us to calculate the quantity of components required for certain lot size of the parent or the final assembly. So here is another example of bill of material that we saw in the last lecture as well. So for example, in order to make 50 tables, we will need 50 bases and 50 tops, and we need 50 into 4, 200 legs, and 50 into this 4, 200 leg bolts and 50 frames and so on. So in this case, we can make calculations. So in order to make 50 frames, we will need 100 sides and 100 ends and 200 leg supports, and correspondingly for 50 frames, we will require the quantity of glue. So this is the process of exploding the requirements. So here is another example. Using the following product structure, you have to calculate how many Ks are needed to make 100 X's and 50 Ys. So we need 100 X and we need 50 Ys. And K is actually the component of both X and Y. So we are pooling the requirements for K. So how many Ks we need if we have to make 100X and 50 Ys? There is the same process, but of course, the level of the product structure are greater than in the previous case. So we have to calculate the quantity of Ks required to make 100X and 50 Ys. So again, we will use the process of exploding. So each X requires 2 Bs, right? So each B also requires 2 Gs. And each X requires 4 Gs. So 2 into 2, 4. So each X requires 4 Gs. So 100X requires 400 Gs. Now each Y requires 1 L and each L requires 1 G. So 50 Ys require 400 Gs. each L requires 1 G, so 50 Ys requires 50 Gs, because it's there. If there is no quantity, that means 1. So each Y requires 1 L, and each L requires 1 G, so 50 Ys requires 50 Gs. So we need total 450 Gs. 450 Gs. And now each G requires 2 Ks. So 450 Gs requires 900 Ks. So this is a simple process of exploding, using which we can calculate the requirements for components. Or in other words, we can say that there are 800 Ks required for X and 100 Ks are required for Y. So I hope that this is clear. So this process is called exploding the requirements. The third important input to the MRP is inventory record file. And there is such file in the ERP system for each of the components. So it is having a lot of information, and this is a dynamic file. So information keeps on updating whenever there is some transaction. So this is the inventory record file for certain part that has a number 10564. This is the gear housing. The unit of measure is each. It could be dozens, or it could be some other unit as well. The order quantity is fixed order quantity of 50. So whenever we have to purchase this item, if it is a purchased item, we have to purchase a quantity of 50. Or if we are making this component in-house, then the batch size of the production of this component is 50. So that is the fixed order quantity of 50. And then there are some codes that are being used by the organization. The lead time is 3 weeks. So if it is a purchased item, this is purchasing lead time. And if it is a manufactured item, this is manufacturing lead time. So if the units are weeks, it is 3 weeks. If the units are days, these are the 3 days. The standard cost is 108. The prime location where this is stored is this warehouse, or the store 12C3. The drawing number of this gear housing is this. And there is the revision number and the planner or buyer, the code for the planner or buyer. Now the last cycle counting of this component gear housing took place on 22nd March. And you could see that because of that counting on 22nd March, there was a difference of one component found, -1. So records showed one component greater than actually there was physically. This gear housing was physically less in number than the record showed. Last receipt was on 4th January. So the quantity of 26 were received on this date. Sorry, this is 1st April. This is American style. So this is the 1st April actually. So the last receipt was on 1st April. And last issue was on 6th April, a quantity of 23. Year to date usage has been 190. Till 6th April, we have used 190 gear housings. And this month, we have used 23 housings. The on-hand inventory is 17. 7 items have been allocated, so the balance is 10. And there are 20 on order. The components, 22 components are on order that we have not received. There is no safety stock that we are maintaining for this component, for this item, and scrap factor is 10%. So whenever we have to order a 10% greater. So for example, we had a quantity of 52, 15 were issued on 28th of March, so we were left with 37. The counting resulted in a quantity of 36 because of one item was missing. Then there was a issuance of 22 on 27th of March, so we were left with 14. Then we received 26, so we were having this 14 plus 26, 40, and then 23 were issued, so we are having 17 left, out of which 7 are allocated. So this is a very dynamic file, and it keeps on updated whenever there is some issuance or there is some receipt of an order or there is some allocation. So an important factor is the numbering system for the components or the coding system. So as I mentioned in the last lecture that there could be alphanumeric coding or there could be only numeric coding. So there are some important points to be kept in mind. Every part should have a unique number. The organization should use a single numbering system. So it is a numeric, alphanumeric, or whatever is the coding scheme. For example, first 2 digits might show the product family, the next 2 digits might show the certain variant of the product family, and last 3 might show some specification of that variant. So whatever is the coding system, that should be same throughout the organizations. It is recommended to use numbers only, and shorter the number, the better it is. And it is important to train the person in the coding because it is a science and it requires a lot of thinking and effort. Do not use suppliers' numbers. The organization should have its own unique numbering system. Complex format should be avoided, and do not reuse numbers from the retired items, as we saw in the previous case that item 200 was retired and it was replaced with item 201. So we should not use the number 200 for the new items. Instead, we should assign a new number so that we can keep a record of the items that are no more. And the final input are the planning factors. And important planning factors are the lot size. We will see on the next slide what could be different lot sizing policies. So the lot size is the standard amount of an item that is ordered. Second important planning factor is the lead time. So a span of time required to perform a process. So it is a purchasing process. It could be purchasing lead time. That is the time required to purchase an item or a lot of item. Or if it is a manufactured items, then lead time will be the time required to make or produce that item. So we can estimate this time from historical knowledge. And lead time for purchase orders can be based on an estimate or on historical average as well. Another important factor is safety stock, the amount of extra inventory deemed necessary to prevent a stock out due to natural fluctuations in demand or supply or to protect against forecast errors. And scrap factor could also be included. Generally, safety stock is maintained for critical items, and the shortage of which might pose some serious problem to the production. So the lot size policies could be different. One of them is lot for lot. So lot for lot mean order exactly what is needed. So if you require, for example, 55 items, then you should place the order for 55 items. The second lot sizing policy is fixed period requirements. So when a net requirement occurs, the requirements falling within a present fixed number of periods will be added together and used as a quantity for the new planned MRP order. So you are, for example, placing order for the requirements for next 2 weeks. So whenever you are placing order for certain period of time. So that is fixed period requirements. Multiples of a standard lot size. So for example, whenever you are placing orders as multiples of 100. So either you will be placing order for 100 or 200 or 300, for example. So the suggested planned MRP order quantity cannot be less than the standard lot. So requirements over the standard lot must be replenishing using multiples of the lot. Discrete above the standard lot size. When a net requirement occurs, suggested planned MRP order quantity is a standard lot. For requirements over the standard, the system will suggest a planned MRP order quantity that matches the requirements exactly. For example, your lot size policy is 100, and whenever you will place order of 100. And if the order is greater than 100, you will place the exact order. So for example, if the requirement is for example, 90, you will place an order of 100. When requirement is say 95, you will place an order for 100. But for example, when the requirement is 110, you will place an order of 110. So for quantities greater than 100, you will place the order equal to exact quantity. Another possibility is incremental above the standard lot size. So there is a lot size, and above that lot size, you have some increments. So for example, below 100, you will always place an order of 100, but above 100, you will use some multiple, say multiple of 20. So if there is a requirement of 110, you will place an order of 120. For a requirement of 112, you will place an order 120. But for 125, you will place an order of 140 because you are using multiples of 20 above the standard lot size. And another possibility is to use min-max order quantities. So in min-max, we have a certain minimum quantity and a certain maximum quantity. So you will make sure that the quantity of that item does not fall below 50, but does not exceed 200. So these are different possibilities of lot sizes that you can use. So there is a simple question, a couple of questions. The first one is that the order policy indicates standard lot size of 600 units or its multiples. The net requirement is 700 units. The planned MRP order is for a quantity of how many units? So we will have an MRP order of 1200 because we will always be place an order as a multiple of 600. Okay. The order policy indicates discrete lot for lot policy. The net requirement is 515 units. The planned MRP order is for a quantity of how many units in this case? So as we are having lot for lot, so whatever is the requirement will be the planned order. Okay, another question. The order policy indicates an incremental quantity of 25 units above standard lot size of 500. The net requirement is 510. The planned MPS order, in fact, it should be MRP order, for a quantity of how many units? So whenever there is a requirement, we will place an order of 500, but above 500, we will have multiples of 25. So in this case, the requirement is 510. So we will place an order of 525. So this is the summary of our discussion so far, that MPS gives input about the quantity of end items and when they will be required. Bill of material gives the number of components required for a certain quantity of end items. Inventory data or inventory file updates us about the current status of the inventory of a specific item. And planning factors inform us about the lot sizing policy, the lead time, the safety stock, etc. And the outputs, there are actually two main outputs to the MRP process. Now, if the component is being purchased, then the output will be the purchase order or PO. And if the component is being manufactured in-house, the output will be the production order or the job order. And there is third output that is not actually the regular output of the MRP process, but that is one of the core benefits of MRP. They are called action messages or exception messages. Now, action or exception messages are the alert. They are sort of alert by the MRP system if there is something abnormal that is happening. Some order is getting late, some order needs to be expedited, or requirements are changing. So there is a pop-up or there is an alert by the MRP system that suggests the planner to take appropriate action. So that is called action message or exception message. And keep one thing in mind, that MRP as a whole never generates order. MRP itself never generates orders. I mean, it never places orders. It only suggests the planner to place the order, and final decision is of course taken by the planner. So this is true for regular planning as well as in the case of exception or action message.